Today, we're going to learn about how to simplify rational expressions. So pretty much it's just factoring. That's pretty much it. So you're factoring like the top and you're factoring the bottom, and then you are going to see if you get anything you can cancel out. And so by cancel out, you're going to get some repeating terms on the top that might repeat on the bottom. And they can cancel each other out because anything divided by itself is 1. Cool. So if you don't feel the best on factoring, or if you struggled in the past, that's all right, because this is like a second chance at factoring. You want to either do big X or greatest common factor for all of these problems. So you kind of have to ask yourself each time, is it a greatest common factor problem, or is it a big X? I like to tell students if it's in this format, like ax squared, bx, and c, and these are coefficients where this is usually a 1, this is usually the big X. And then if it only has 2 terms, it's usually greatest common factor. So if you can't do a big X and it's not 3 terms, you want to try a GCF, which is greatest common factor. So those are the 2 main things. So if you looked at like this first one and you looked at the top of it, so you want to take like the top separate from the bottom, and you were trying to factor it. And I sometimes will go like top, and I'll be 10n plus 60, and then I'll factor the bottom on this side and then put it all together. So just getting my paper squared away there. So these two, since only 2 terms, you're going to look for greatest common factor because it doesn't have squared either. So you can't really do anything with that. Does anybody know what the greatest common factor of 10 and 60 is?
10.
Oh, great work. Great work, anonymous student. So we have our 10. Good. So when we divide, we just want to make sure this is what people always forget. To put our 10 on the outside of our parentheses. So we're going to do 10 divided by 10. And you could just cancel that out and just put a 1 in. I don't really like invisible ones unless I need them. So I just bring down an n. And then 60 divided by 10 is our positive 6. So I like to let people know that even in Algebra 1, that like might not have mattered that much to have that greatest common factor chilling on the outside, but it actually is really important when you are factoring these because it's a big game of canceling stuff out. Now on the bottom, you also want to look for a GCF because there is this 2 in front. And so I like to let students know that whenever there's a bigger number, you got to look with GCF first. That way, big X is a lot easier. Sometimes, if you go to Ivy Tech or you go to college after this, there may not always be a GCF. But in our case, we're working with problems with greatest common factor. So we're going to always check for the front number, and coincidentally, they all do divide by 2. So it kind of works out nicely. And sometimes I run out of paper, so I use a little sticky. But if you're a student working on this and you go off the paper onto the next problem, it's really not a big deal. Or if you need a piece of scrap paper and need to attach it, I just trying to save the planet and just only print so much. So I like to go ahead and divide it first. So I'll get n squared because these technically cancel out. And 16 divided by 2 is 8. And we got to drop that n down because there's an n on the 16. And then 24 divided by 2 is 12. So after we factor out the GCF, we can put that on the outside. But if you look at this one that we did in pink, does anything tell you I need to go further with this and maybe do a big X? Does anything stand out to you that might tell you to do that?
A squared plus B squared plus C.
Exactly. So we have this kind of template here. Beautiful. So since we have a squared, we can break it down to a big X. Sometimes I kind of write on to the next problem and then I might do that one on a sticky, depending on how I feel the video is going. So if we do our big X here and we're looking for numbers that multiply to 12, and then we want to add to 8, you could also think subtract to 8 if that's easier for you. But usually, especially if you're using your calculator, I just think addition and multiplication to start. So any factors of 12 so things that multiply to 12 that add to 8 that we know of. 12 divided by 1 is a little too big.
You have to clue to get plus 6. And you can get 6. Most likely it's going to.
You do have a clue. So you can kind of look at what the other part factored to, and that is very helpful. Yeah, because we want to think about canceling something out. You could think about it that way. Yeah. And if you're a person who struggles with factoring, what I like to do, since you already said 6 and 2 times 6 is 12, what I like to do is I'll take my calculator out and I always start with the top number and I just divide it until I get 2 numbers that add or subtract to 8. And since it's a positive 12, I know that they're both going to be either both positive or both negative. So since this bottom number is positive 2, I know they both have to be positive, and I can just try out until I get 2 numbers that are going to work for me. Yeah, just a little calculator trick. You can also use a multiplication chart as well. So those can be helpful. Yeah, and when you get those, you'll put your 2 parentheses and you'll put an n in each, because we know n times n is n squared. And then our 2 and our 6 go in each parenthesis with our 2. So once we have our top and our bottom factored, we're really just looking for anything that is the same, because if it's the same on the top and the same on the bottom, it'll cancel each other out. So do we see anything that's 100% the same between these two?
N plus 6.
Good job. Getting some good different student voices involved today. Very good, very good. So we can cancel out the identical ones. You can also reduce, so we'll talk about that at the end. This is where I need my sticky because I write too big for you guys, and that's okay. This is how my class goes down too. Whatever's left over on the top goes on the top, and whatever's left over on the bottom goes on the bottom of the fraction bar. So you're going to rewrite your answer in a fraction form like we started with. The 10 and 2, I'm going to be real. If you're on a quiz and you stop here, I'm going to count it because I feel like you did most of the heavy lifting, but you could also reduce this because they're both divisible by 2. You could make it 5/1 or just a 5 on the top as well. So it could be 5 over n plus 2, which you don't need the parentheses on anymore either, because it's the only thing. So I'll take either of these as a final answer. Just know if you're going to Ivy Tech, you're taking a placement test, you might go a little bit further, or really any sort of standardized test potentially in your future. Yeah, so most of them are pretty similar. The only, I guess, one that was a little different on here that I didn't realize I included was number 6, but most of them are either GCF or Big X. So we can do one that has a GCF that is just a little bit different. So number 3 might be a good one to do because it has that x squared and it also has x for both of these. So it's a little bit different in terms of the GCF. So if you write out your top, you don't have to write the word top unless you want to. Have your bottom. So that way they're kind of 2 separate problems. You want to look for GCF because they're, not in that ABC. So it can be hard to find your big X. So I know 3 goes into both of those, but they also have a variable. So since one of them has an X and one has X squared, they at least have 1 X apiece. So we can also divide them both by X. If you're an invisible 1 person and that helps you to kind of know when they're stacked, I subtract, you can do it that way. I've had students in the past that need to write out 2 X's on the top and 1 X on the bottom and then cross it out. So it just depends on the student. So we have 15 divided by 3 is 5. And then our X's subtract. So there's an extra X on the top portion. And since everything's on the top of the fraction left over, we can just leave it 5X. Over here, these X's will cancel because they're the same exponent. And 27 divided by 3 is 9. Got to carry down my negative. So it's a little bit bigger GCF problem here is that X. So we've got to remember to put our 3X on the outside since it's our greatest common factor. So these ones always seem to be a little bit tricky for students because they both have X. So if you struggle with it at first, just grant yourself some grace and go back in there and try it out again and put that X in there. The GCF for this one, does anybody know what the greatest common factor is of 9 and 3? And maybe what to do with these X's?
I'm guessing it's 3X.
Perfect. Good. Very good. And that's kind of nice because they both have that greatest common factor of 3X. So that's going to come in handy. Good. Put our GCF on the outside. And when we divide this one, it's the same thing. We can put in those invisible ones. We can cancel out those X's. So we're left with 3 because 9 divided by 3 is 3. And these X's cancel out to give me 1 extra on top. A lot of students will ask me if they can cancel out these 3's. Technically, yes, but there has to be something as a placeholder. So since 3 divided by 3 is 1 and it's a -3, it's a -1 there. So we just don't want to forget to put something as a placeholder. So we look just like we did on the last one, anything that's identical and kind of together. So what I mean together is they have to be touching or they have to be identical in the parenthesis. So we can't just like cancel n plus whatever and n plus another number. They have to be the same. So over here, we can cancel the 3X's out because they're identical. And then we can use whatever's left on the top, which this was the top factored down. We can write that on the top of our bar. And on the bottom, our 3X minus 1. And the reason that these X's cannot cancel out is because that 5 is tethered with that X and that 3 is tethered with that X. And they also have a constant attached to them. So that's something I've seen people try to do, but we unfortunately cannot cancel them because they're not identical. Good. So looking ahead at this, a lot of these are very, very similar. I don't think we're going to worry about number 6 because I should not have put that on the note sheet. That's not on our Unit 3 quiz, either of them, or the final, so you don't have to worry about that. Are there any that speak to you that you might want to do out of the 3 of these? You feel like you're good? Yeah, most of them are very, very similar. So if you can do number 3, you can do number 5. And same thing with number 2, just kind of identifying what the greatest common factor is and then canceling out anything that is the same. Wonderful.
Awesome.
Great work today. Excellent. Now everyone knows how to simplify rational expressions, and thanks for your help on this one.